Hi everyone. Let's continue our discussion on evaluating the derivative using a chain rule. So now we're going to start at number 16. Okay. All right. Let's go ahead and review our shortcuts for square roots. Let's say you have to find the derivative of square root of 3x plus 5. Okay. Now, previously we covered like if we have a simple square root of x, the format for the derivative of that square root of x is always going to be 1 over 2 square root of x. Okay, so of course you can use the long way to get to that 1 over 2 square root of x, but I will just recommend for you to memorize it. Now, if the radicand is not a simple x, let's say we have a 3x plus 5. Now, to find the derivative, it's just going to be the same form. It's 1 over 2 square root of that 3x plus 5, but you just have to multiply it by the derivative of this 3x plus 5, which is 3. Okay, so now we have this 3 over 2 square root of 3x plus 5. All right, so we have that one single additional step to do. All right, let's do what number 17. Let's say you have this 8 square root of 3x plus 5. So what is the derivative? All right, we have a constant in front of the square root. So what we do is just go ahead and bring it down and apply your shortcut to that square root, which is 1 over 2 square root of 3x plus 5. And go ahead and multiply it by the derivative of this 3x plus 5, which is 3. And then simplify. So this 8 over 2 is 4. 4 times 3 is 12. Okay. So we have 12 over square root of 3x plus 5. Right? Let's look at number 18. Okay, one more square root example. Okay. This time we have a constant as our denominator, say 5. So what is y prime? Okay, so y prime is going to be, now this over 5, you can always pull it out. Okay, so you can always pull it out because that's your constant, and then go ahead and apply your shortcut to finding the derivative of that square root of 3x plus 5, which is 1 over 2 square root of 3x plus 5, and then multiply by the derivative of the 3x plus 5, which is 3. Okay, and that's it. You just have to simplify. That's 3 over 10 square root of 3x plus 5. Okay, suppose we have number 19, okay, which is, I'm sure you still recognize this. This is another shortcut that I gave in the previous video. So this is a reciprocal, okay? And the way we deal with the derivative of reciprocal, we know it's a reciprocal. Again, if the numerator is constant, and you have the variable plain x raised to some exponent as as your denominator. So we have a reciprocal of x, 3 over x to the fourth. And the shortcut is you multiply this 3 and 4, that's a 12, over that same x to the 4, but you add 1. So now it's a 5, and then always switch the sign. And that's it, okay? Let's say another reciprocal example, 3 over x to the fourth, but raised to the second power. Okay, so what is y prime? Now the base here, which is 3 over x to the fourth, is a reciprocal, and that is raised to the second power. So the best thing or the easiest thing to do here is to go ahead and distribute this exponent 2 outside our parentheses. That means we have a 9 over x to the 8, okay? So that's going to be 2 times 4 is 8. Hold on, this is not yet the derivative, okay? So this is still just renaming. So the derivative is going to be, all right, going to start here, multiply 9 times 8. This is a shortcut for reciprocals. It's equal to 72 over x to the 9. Okay, so you always add 1 to the exponent of your denominator, and then you switch the sign. Okay, otherwise you need to use the chain rule, which is a little more tedious to do. Okay, so this is more efficient. 21. Another reciprocal example. Let's say you have a negative 2 over x to the 5th. Now this reciprocal is raised to the 3rd power. So what is the derivative? So the derivative, let's say this is f prime of x, is going to be what? All right, so we can rename this first, okay? So by distributing the 3, so this is negative 8 over x to the what? 5 times 3 is 15. So we rename the inside expression. Now we can get the derivative. So this is a reciprocal, constant numerator, and then variable x raised to some exponent in the denominator, okay? So you have a reciprocal, and then you can use the shortcut. So what is 8 times 15? It's a big number. 8 times 15 is equal to 120, okay? Over x to the 15 plus 1, 16. And don't forget to switch the sign. So now it's a positive. Okay, number 22. Let's move on to trigonometric function. So we memorize the derivative of the 6 trigonometric functions. So let's say what is sine of x prime? So it's cosine x, right? What is the derivative of cosine x? It's the negative of sine x. What is the derivative of secant of x? It's secant x times tangent x, okay? And the derivative of cosecant x is negative cosecant x cotangent x. What is the derivative of tangent x? It's secant squared x. And the derivative of cotangent x is negative cosecant squared x, okay? It would be best to memorize these 6 derivatives, okay? So let's say you have to get the derivative of sine of 3x. So this is plane x. So what we did is just a power rule, cosine x, okay? If you make it a generalized power rule, you can go ahead and multiply this by the derivative of x, which is just 1 anyway. So that one extra step makes it a chain rule, okay? So what we do to get the derivative, say y prime, is get the derivative of sine, which is cosine. Okay, you have to copy this thing here. It has to stay 3x, but you have to multiply this by the derivative of this 3x, which is 3. So our derivative is 3 cosine of 3x. Okay, so let's see another example. Let's say you have y is equal to cosine of 5x squared. So y prime is derivative of cosine is negative sine. Okay, just bring this down, same 5x squared, but make sure you multiply. It's a chain rule now. See, chain rule. Multiply by the derivative of the 5x squared, which is 10x. Rearranging this, now negative of 10x sine of 5x squared. Okay, next, let's say you have to get the derivative of tangent of negative 10x cubed. So what is y prime? The derivative of tangent is secant squared of that same negative 10x cubed. But make sure you multiply by the derivative of this negative 10x cubed, which is using power rule within is negative 30x squared. Okay. Organizing, we have negative 30x squared secant squared of negative 10x cubed. Okay, number 25. What about if we have a secant of 12x plus 1? What is the derivative? Okay, so again, derivative of secant is secant tangent. Okay, so we're going to copy this angle twice. Secant tangent of 12x plus 1. And then we're going to go ahead and multiply it by the derivative of that 12x plus 1, which is times 12. And there you go. That's our derivative. 12 secant of 12x plus 1 tangent of 12x plus 1. Okay, number 26. Let's see cosecant. Let's say cosecant of 13x minus 2. What is the derivative? The derivative of cosecant is negative cosecant cotangent. Okay, so negative cosecant 13x minus 2. 13x minus 2. But make sure you multiply by the derivative of this 13x minus 2, which is 13. So y prime is negative 13. Just going to put that negative right out front. Okay, so negative 13 cosecant 13x minus 2 cotangent 13x minus 2. All right, number 27. Let's see cotangent this time. Let's say y is equal to cotangent of 4x cubed. What is y prime? The derivative of cotangent is negative cosecant squared of that 4x cubed, but multiply by the derivative of the 4x cubed, which is what? 12x squared. Okay, so using or applying power rule to that 4x cubed. Okay, so we saw all the 6 trig function with the angle that's not plane x. Now, how about if we see something like this? Sine cube of x. Now, we know that this is the same as sine of x raised to the third power. Okay? In other words, our base is not plane x, but sine x. So this is a very clear chain rule example. So what we do is, all right, so we're going to use the initial step, which is power rule. So let's say 3 times 1 is 3. Copy that same base, sine x, raised to the second power. So that's actually chain rule. Sorry, that's actually power rule. And with this one extra step, see, plus 1 extra step. This one additional extra step makes it a chain rule, which is finding the derivative of that base sine x, which is cosine x. Okay, so that's why it's called a generalized power rule or simply chain rule. So y prime is, you can reorganize this into 3 cosine x and then sine x squared or back to sine squared x. Okay, number 29. Let's say we have y is equal to cosine to the fifth of x. Renaming, this is equivalent to what? Cosine of x raised to the 5. The reason I rename it this way, so you can see very clearly the actual base. And so that when we use the chain rule, okay, 5 times 1 is 5. Okay, copy that same base cosine x to the fourth. So you multiply it by this cosine x, by the derivative of cosine x, which is negative of sine x. Okay, so I want to rewrite it where the exponent is written outside the parentheses, so you can see very well what the base is, because you're going to get the derivative of that. So y prime is negative 5. So I'm going to multiply this by negative 5. Sorry, by 5. So we have negative 5 sine x and then cosine x, or cosine to the fourth of x. Or you can actually write this as negative sine x cosine to the fourth of x. Okay, so let's look at number 30. Okay, how about if we had secant to the seventh of x? So that is again the same as secant x raised to the seventh power. And I can add, let's say, 2 here. Okay, so 2 secant to the seventh of x. Now the seventh power is only applied to the secant. Okay, so I just added the 2. That means if I'm going to, okay, raise something to the seventh, it's just going to be secant x. Now this 2 has to be written outside that. So your y prime, using the chain rule, is 7 times 2 is 14. Okay, copy that same base, secant x, to the 6, and then go ahead and get the derivative of that. Okay, the derivative of secant x is secant x tangent x. So that will be our derivative. Now we have this secant to the 6 of x times secant x. That makes it what? Secant to the 7th of x, then tangent x. Okay, I just multiply these two secant together. That's why we have the secant to the 7th of x, and then times tangent x. All right, let's look at the last 3 examples. Say 31. How about if we have tangent squared of 10x? Again, rename that into tangent of 10x. Okay, and then everything squared. All right. Now, this one, we're going to have like double chain rule, because to get the first step derivative, multiply 2 and 1, we get the 2. And then copy that same base, tangent of 10x. Now raise to the first power. Now, what is the derivative of, see, what is the derivative of tangent? Because we're going to multiply this by, see, what is the derivative of tangent 10x, right? So we're going to multiply it by the derivative of the tangent 10x. So what is the derivative of tangent 10x? The derivative of tangent of 10x is going to be what? Secant squared 10x. And then, because it's not plain x, you have to times 10. So this is 10 secant squared 10x. Okay, so that is the derivative of this tangent 10x. So times 10 secant squared 10x. Okay, so now our final derivative is 2 times 10, which is 20. Okay, tangent of 10x, then secant squared of 10x. It's like double chain. Let's look another example using double chain. Let's say you have y is equal to, say, cotangent squared of 5x. Okay, so this is clearly cotangent of 5x and then raised to the second power. So the y prime is going to be 2 times, okay, cotangent of 5x raised to the first power, and then multiply this by the derivative, okay, of cotangent 5x. Okay, so what is the derivative of cotangent 5x? The derivative of cotangent 5x is negative cosecant squared 5x times 5. Okay, So we have negative 5 cosecant squared 5x. So this one goes inside this box over here. So times negative 5 cosecant squared of 5x. And then organizing it, negative 5 times 2 is going to give us negative 10 cotangent 5x, okay, and cosecant squared 5x. Okay, let me show you number 33, our last example for this second part of the chain rule series. Say we have cosecant to the fourth of 7x. So again, rewrite this as cosecant 7x and everything raised to the fourth power, okay? So what we do is use the chain rule. So 4 times 1 is 4. Copy that same base. Now raise to the third. And then multiply it by the derivative of the cosecant 7x, okay? So we multiply it by the derivative of cosecant 7x. So what is the derivative of cosecant 7x? Okay, the derivative of cosecant is negative cosecant cotangent, and then multiplied by what? Multiplied by the derivative of the 7x, which is 7. So the derivative of cosecant 7x is going to be this right here, okay? And that goes inside this box. So multiplied by negative 7 cosecant 7x cotangent 7x, okay? And then finally, we just have to organize it. 4 times negative 7 is negative 28. Now this 3, you can write it back to that position, cosecant cube 7x, and then times another cosecant 7x cotangent 7x. Now, if you want to multiply these two cosecant together, that's going to give us cosecant to the fourth of 7x, then cotangent 7x. Okay, so I hope you learned something from this second part of the chain rule series. Okay, so I appreciate you for watching, and I'll see you again on the third part.